So, good. So today we are going to talk about the last very important hook in React, useEffect. Okay, I put the slides online yesterday together with the examples that we are going to test today and the next lectures. Okay, because you see the schedule for next week as well, and well, we will have a short discussion about course because now that we introduced the server, there are some additional issues we need to discuss. But I mean, the discussion about useEffect, that means component lifecycle takes quite a lot of time. Okay, because it's a really very important element we need to understand very well. Okay, and then at the end of next week, not this week, we will start about authentication and so on. Okay, talking about authentication and so on. Okay, so this week there will be 2 labs, so the usual lab tomorrow on Tuesday, plus another lab on Thursday morning, okay? As I already announced in the previous weeks. These are about forms and router that we saw last week, okay? Okay, good, so unless you have any questions, I think we can start discussing the topics for today, which is, oops, sorry, slides, life cycle, okay? Quite a number of slides, as you can see, but I mean, we will not do everything today. So, it's like making React components live, okay? I mean, it's just a joke, of course. But I mean, the truth is that there is live, so it means React does things before and after the return JSX, okay? So after it runs the function that determines how the user interface should appear for each component, okay? These are the events, and actually the state, it's a state machine that React implements. It's a very simple state machine. There is an initial state, there is a state where we update the view, and there is a final state. Just we call it differently. We call the first state mounting. Okay, so first the component is mounted. So when it appears in the virtual DOM tree, we say that React mounts the component. Okay. So the component is being created in the React memory structure and it is inserted inside the DOM, okay? First in the virtual DOM and then in the actual DOM automatically by React. Okay, and then events happen. You know that in web applications, event happens. User interacts with the application. The server gives answers to questions and so on, I mean to requests, etc. And events happen. And so whenever it's necessary, React updates the render, the aspect of the component. So the component is being re-rendered. And that is what we saw basically until now. We say that React re-renders the component every time a props or a state that belongs to the component change. Okay, so every time a props or a state change, React does the update. So that's the meaning of this loop arrow. And then at a certain point, the component ceases to exist. It doesn't exist anymore. Okay, so we say the component is unmounted. When does this happen? Well, simply when this component is not returned in the return of all JSX of the components anymore, okay? And this may happen because of many reasons. We already saw a case during last lectures. There was that state show form. If the show form is true, we show something, means we return something, some component, or we return another component. The component that is not returned anymore gets unmounted by React, okay? So simply React frees the memory and destroys the state of this component, if there is any state, and just releases the memory and simply it doesn't render it anymore in the virtual DOM and so in the DOM. On the contrary, maybe something else starts to appear, so it's mounted by React. That's the way in which things are handled by React regarding the components. Okay? So there are 3 states, the initial one, the final one, and we need the final one because maybe we want to do something on unmounting. It's pretty unusual, I mean, a very simple application, but maybe we need to do something. And there is the updating state, which is the most common one, that is the one we talked and we thought about until now. Okay? It is useful to customize what happens at different moments in the evolution of the component, like at mount time. Okay? That's a topic for today's lecture, for instance. Not just mount time, but I mean, most of the time we will talk about mount time. Okay? But how can you attach some code, that means functions that you write yourself, to the mount event of a component? At the moment, we have no way, because we only know that the component is being rendered. But is it the first time, the second time, the third time, whatever time? I mean, we don't know. Actually, maybe we could write some code, try to hack the system and so on, but I mean, that's not a clean way of proceeding, right? So let's see if React provides us some mechanism. Why it can be useful to intercept this event, the mount of the component? Think about our table of films in your lab, table of answers in our example during the lectures. I mean, we want to populate the content of the table, right? At the moment, it's just written statically inside the JavaScript code. I mean, we would like to say the server, please give me some information about what I should show, okay? And that's a typical action you do at mount time for a component that contains some information you want to display to the user, okay? That's the let's say, most trivial use case, but I mean, very important, because without this use case, I mean, we cannot really load the information from the server. Okay, so life cycle of React hooks. I mean, in short, I mean, we need to keep in mind that, I mean, there is this render phase that we already talked about. We always talked about the render phase until now. And this should be pure, okay? We say it has no side effects. We cannot do computation that doesn't depend on the props passed to a component, okay? And this is completely under React control, okay? We don't know when React decides to call the function that corresponds to our components. React may pause the render phase, may abort the render phase, may restart the render phase, and so on, depending on the events that happen and so on. But since functions are pure, so the result depends only on the props that are passed, React always knows if it's needed to call the function again or not. Because if props didn't change, there's no need to change anything. If the state didn't change, there's no need to change anything. In fact, you find the use state and the context as well here. Okay, the context is just a way of transporting props, right? And then actually React works with this second stage that always happened, that until now we didn't actually see very clearly, because we had no way to attach events, attach code, to events that happens during the commit phase. And in this commit phase, of course, React does what I already told you in the first lecture about React. So it computes the new virtual DOM, the difference with the old, and the differences are used to update the actual DOM in batch. Okay? So React updates the actual DOM in the browser. Of course, this happens at mount time of the component, at updating time of the component. When the component is unmounted, there's nothing to update. I mean, things should disappear, right? Okay, we could have extended this here just to say it disappears, but I mean, just probably not so necessary, okay? What instead is useful to know is that we can attach code to this in this commit phase, depending also on the phase in which we are, mount time, update time, or unmount time, okay? And there's a hook which is called useEffect that is provided by React exactly to do this operation. Okay? And now, of course, we are going to talk about this hook. But first of all, what is the side effect? I already told you, I mean, everything that does not depend on the parameters that have been passed to the component and has and modify something outside the component itself, and it's not a part of what is returned, it's a side effect. But just being a bit more practical, the side effect is any calculation that does not target the output value, anything that affects something outside the scope of the function component. For instance, first example, very, very important example, data fetching, okay? Asking the server for data, okay? This is extremely important. I mean, you cannot submit your exam without asking the server for data or sending information to the server and so on. Because, I mean, it's a trivial application. It's just a sort of hello world, okay? So, and in actual application, you indeed need to interact with the server. And today, we will start interacting with the server. And then, maybe you can, you know, do other operations like recording logs, subscribing to something, scheduling actions when something changes, and so on, managing timeouts, managing intervals, etc. Okay? But I would say the most important operation, and the one on which we will focus today, is data fetching actually from a server. Right? So, the component rendering and side effect logic are independent and should be kept independent. Okay? In practice, we will write them inside a function. I mean, I'm talking about the side effect logic. We will write code inside a function that is written inside a component, but actually not executed by the component itself. It just, you know, passed through this useEffect hook to React, and React knows that it has to associate this code to this component, but it's not run when the component is rendered. Okay? So it would be a mistake to perform side effects directly in the body of the component. Okay? So, in short, no side effects are allowed in the render phase, so we shouldn't write code inside this function with the name of the component, props, etc. here, because, I mean, this is supposed to be a pure function, okay? And React can restart it and re-execute it again when it wishes. Okay? So, I mean, we have no control on this. If we want to have control on this, we need to use this useEffect hook and tell React that we want this code to be executed in certain situations. It means at mount time, during update, after update, before unmounting, and so on. Okay? And the useEffect API, so this hook, is specifically designed for this purpose. So now we are going to discuss it. Okay, so in short, on the left you see what's wrong, so on this pale red, and in green what would be right, okay? So, really bad. Console log is a side effect, because every time you render, you do something which goes outside the return, right? I mean, it's not used to do, I mean, it provides, it creates an effect that is not computing, not necessarily related to computing the result of the function, right? And it creates this effect again and again if the component is, the component function is called many more times, even though it has the same props, right? Because the console log is always executed here in the code. Of course, I mean, we did it, right? Because it's so convenient. And of course, we know that React could in principle call the function again and again. But sometimes, I mean, for debugging, let's say, we tolerate this. But I mean, in general, we couldn't do real logging, okay? When we are in the code of a component, okay? Because we risk having the log entry written many times instead of just once, okay? As we would expect. Even worse if we do other operations like go to the server and load user information and so on. That's wrong because, I mean, not because we cannot do it, but because we don't know how many times this will be done. And I mean, if it's just loading information, there's no effect on the server apart from loading the server. But if it stores information, we cannot just send 2 requests to the server because it would store information twice and so on. Okay? So we have no control about when React decides to re-render the component because it depends on what the user does and what the props and the state is and so on. Okay? So we should not do something like this. We should do something, as you see on the right, passing the action we would like to do, console log, load user info, and so on, as part of code of a function that we pass to a specific hook, which is called useEffect. Okay? So all side effects must be confined within a hook, and in our case, the useEffect hook, and the hook controls their execution. So when this code is actually executed, and we will see now how how can we control it. How can we control it? Well, it depends on the second parameter. But actually, I must tell you, this useEffect API is quite complicated. I mean, at least in the definition. You can have a look at the manual, React manual, or React documentation, and you will see all these cases and so on. But I mean, in principle, you just pass a callback that contains a code. Okay, that's JavaScript. When you want to pass some code and have code to be executed later, you pass a callback to a function. And then there is an array that decides when to execute this code. Okay? So, useEffect executes the callback function after React has committed the changes to the screen. So, here, okay, in this commit phase. So first it determines the return values of all the components, and then when you decide to commit the things to the screen, so to the actual DOM, it then runs the callback. Okay? Callback may return a cleanup function, we will see it later, and there is a list of dependency, an optional array of dependency, but I mean, in our case, if we basically always specify this array, empty array or with some dependencies, and you useEffect to execute the callback only if at least one of the dependencies have changed between renderings. Okay? And if it's empty, it means it will run the callback just at mount time, but it's written later in the slides. So we need to think a little bit about the meaning of all these words here, because as I told you, it's a very dense API. So, the dependency array. Not provided, side effect runs after every rendering, okay? So it's basically useless for our purposes because there's not that much difference from this case, apart from the fact that things are cleaner and are not run during render but after render, okay? But I mean, not really sure about a case where we should, I mean, not provide the array in our simple examples. An empty array, instead, is very common. The side effect runs once, only one time after the initial rendering. Okay? So that means at mount time, component appears in the virtual DOM tree. Good. You can execute code after the component has appeared for the first time in the DOM tree. Okay? And that is the case that I was telling you before. Typically, you want to load some data from the server to fill up the content of the component, I mean a state that then will render this content to the user. And then the third and more complex case has a list of props or state values, and the side effect runs once, so after initial rendering, so this always happens on all three cases, plus then only when any dependency value changes. So there is a list of values. If the list of values stays the same, the callback is not called. Okay? React keep the value of these values inside the dependency array. Is some part of memory dedicated to this component. This is not the state. This is not props. These are just values we pass, but typically are props and state because we have nothing else inside our components, right? And if it detects that something has changed, it runs the callback. If everything stayed the same, it doesn't run the callback. Very simple in principle, right? So let's see some examples. In a minute, I have an example to show you. I mean, we can run an example and see the behavior live from the code. Okay. Okay. So first case, not provided means you write useEffect, you write a function as a first parameter, and then you close the round bracket, the one that you opens the useEffect. Second parameter not present, okay? Or undefined for JavaScript, right? Runs every rendering, but actually, I told you, I mean, not so useful for our purpose. Empty array is that very, very useful. useEffect, open the bracket, which is closed here. A function that tells you, I mean, in which you write the code you want to execute once after the initial rendering, so at mount time. And third case, so useEffect, again, there's a list of props and state. I mean, this is just an example. I mean, we wouldn't write, well, props, yes, props name prop, and, you know, a bit confusing, right? But anyway, some values that if they change the content, I mean the function and the code of this function is executed again and again, okay? And this also runs once after the initial render, so it runs once at mount time in any case, okay? Good, so that's the three cases. Now we'll see this example and we will try this example because I published the code and we can do this, test this example in practice, okay? But first of all, let's have a look at how it looks. So count is a component, React component defined by us, which we are the developers. So we write function count, take some props, and then we can write something, some code, right? The typical code we write until now is return some JSX to show. Okay, very simple. Div with the num, that is the props. Okay, so I mean, really, really simple component, right? We pass a num, and this num is just simply shown inside the HTML, right? But I mean, the interesting part is what we can do with the useEffect. We have a useEffect that only run only once. Okay. We do console log, my static number is, and we print a number, that's fine. And how do we know it ran only once? At mount time, of course. Because the list of dependencies is empty. And there is a list of dependencies. If there is no list, it runs every time, right? List of dependencies is empty just at mount time, and we call it static. Okay, you see here in the print, in the in the output, in the console log output, static appears only once at mount time. And then run at every change. Console log, my dynamic number is props num again, and props num is the value that is used to decide if we should print something or not. Okay? So my dynamic number is 3. Of course, it runs at mount time. Plus 4, 5, 6, 7, 8, 9, 10, and so on. Okay? You see dynamic, and so on. And then, since I wanted to show you something a little bit different, I mean, otherwise it seems every time you change a prop, it runs. Okay? We can say if the value is multiple of 3, number 3, so the rest of the division by 3 is 0, so is multiple 3 is true or false. Okay? So if this value changes, so from true becomes false and from false becomes true, this console log runs. Okay, my multiple flag is is multiple 3, and the dependency is an array with a list of values, so just one value is multiple 3. Boolean, I mean, we don't really care. I mean, typically are Boolean strings or numbers, okay? We don't, I mean, we will talk about this later, but we typically don't use arrays and objects because it's are more difficult to handle. They are references and so on, okay? But, I mean, with true or false is perfectly fine. So every time this value changes from true to false and vice versa, this multiple flag is, I mean, this statement is printed. So it's printed in the beginning at mount time, as usual, plus when it changes. So from 3 to 4, it changes from true to false. But from 4 to 5, it's still false. So it is not, I mean, the code is not run, so the console log doesn't run. And then from 5 to 6, you compute the division, the rest is 0, and becomes true. It prints true, and so on. Okay? So, there is no multiple here, no multiple print here. Just to tell you, just when the value changes. React doesn't know the meaning of the value. It just compares the old value with the new value. The old value is kept by React in some places, outside the component, as for the state. And when the useEffect is called, React recovers these values and checks if the value is the same, it runs the callback, otherwise it doesn't run the callback. Very simple in principle, okay? That's what happens in practice, but before having a look here, let's see the example working, so maybe it's easier. So we open the Visual Studio Code. We are in week 09, lifecycle slide examples, okay? And we have two folders here now, week 09, lifecycle. You have client and server because we will need to have a server at a certain point, okay? For the moment we stay on the client, but in a few minutes we will use the server as well. So we enter the client. Now the client, I mean, in our simple example, is still something that doesn't interact with the server. So it's fine to use it as it is. Let me install it, npm clean install. Npm run dev, open, okay. So let's reload it. Okay, so, well, there's a very simple component, we don't care. I mean, this is the example we care about. Okay, this is the div3, which in terms of components is the count. Okay, so it has props num3 and 3 useEffect hooks, which cannot be displayed because there's nothing to display. There are functions. Okay, so this is the bug that just tell you be careful. There are 3 useEffect hooks. Okay, and let's have a look at the code. Client up. Okay, so in up we have count num3. And then button on click set num I plus 1, okay? Just to change this value. How do we change this value? I mean, either it changes by itself, so there is a timer or something like this, or the user must change it. So I created a state, num set num, use state we start from 3, and then I created a button we can click, could be a link that we can click and so on. So that we update the state with an asynchronous action setting the state. We pass a callback as we saw in the last lectures. We compute the new state from the old one, I plus 1, and just we tell the state, I mean, to update the state. Okay? So the count changes. Let's have a look at the count. Count is in its own file, and that's what is written in the slide, right? So my static number, empty list of dependencies, and my dynamic number props num, multiple flag, multiple 3 is multiple 3, okay, of 3, could have written something a bit more longer. Props num, okay? So how does this work? Let's check. So console, and let's restart. Okay, I guess there is, yes, there's an error because we don't have the server and the rest of the page requires the server, but I mean. So, my static number is 3, my dynamic number is 3, my multiple flag is 3. Good. Why it's printed twice? That's for later. Okay, we are in sort of debugging mode, that's fine. Then, let's do plus number 4, right? No, 4. Number 4, my dynamic number is 4, my multiple flag is false. It gets printed because it was true before. Then we click again, false will stay false, the number will change, it becomes 5. So my dynamic number is 5, but my multiple flag is not printed because it stays false. Now 6 is multiple of 3, so it will become true. So it will be printed again. Let's try. Click. My dynamic number is 6, my multiple flag is true, and so on. And you can go on, and you see this behavior on and on, that repeating itself. Okay? So we understood how the useEffect works. Empty dependency array just at the beginning. Static is just printed at the beginning, not repeated anymore. Otherwise, it depends on what you specify. Okay? You specify something that every time changes, every time things are executed. Sometimes things change, sometimes things are executed. Okay? Good. So this is the detailed timeline of the action that happens. Component count is created, so it's mounted. At a certain time, up is called, it returns a JSX with count is called, and so count appears in the virtual DOM tree. So it's mounted. It has a props.num number 3, it's mounted, function call is called. useEffects are here in the code of the count component. So useEffects are executed, but I mean not the callback, just the useEffect hooks. useEffect is a function, and we are calling it. We are not declaring it. It's already declared by React. Here we are calling it. So what happens? It happens that the reference to this function, console log my static number and so on, is registered, not executed. So is saved by React somewhere in a place which is connected to the count component. Okay? It's placed somewhere, saved somewhere by React. And the same happens for the other two functions. useEffect is called. So actually, at every render, useEffect is called. But then React saves the reference to the function and the list of dependencies. Okay? So all useEffects with yes, all three are registered, not executed. And then the JSX is returned. That's fine. And we have a number 3 here. Okay? As we would expect. Component then enters, you remember the commit phase, right? This commit phase. After the render, we got the return value, we enter the commit phase, and we have 3 hooks, 3 useEffect hooks which have been registered, right? So, the component has just been mounted. We don't care about the list of dependencies. The callback is executed. So the first one is executed, the second one is executed, the third one is executed. Because it's a first mount. And we saw it, right? We saw it in the here. You see? We didn't do anything. We just load the application and this happens. Because count is shown, count is mounted, and so in the commit phase there are 3 useEffect registered, they run the callback. Okay, good. Then nothing happens. Okay, the 3 dot. Nothing happens until something changes, until some events happen. what happens? Well, I as a user, me as a user, I will click, right? Click on the plus. And so something happens. So a state is changed. So app updates a state because of the click. The num props taken by count changes. And so React decides to rerun the function count because one of the props has changed. And that's enough for React to decide that it has to run again the function that defines the component. Because it wants to know the new result, the new return div something that will contain 4, right? Function count is called for re-rendering with num equal to 4 in the props. The JSX is returned, but in the meanwhile, the useEffects are called again, okay? Are re-registered. Actually, the functions are the same, so actually the function will do exactly the same. They're just new functions, but they will do exactly the same. And then React enters the commit phase and decides if it has to execute the callbacks or not. Okay? So the first one, not, because there's no, the array of dependencies is empty. It's not mount time anymore. The first callback will not be called anymore. The second one, well, it depends on the content. Props num is 4, right? Props num is changed. Previous value is 3. Current value is 4. So it runs the second, we say effect, but in practice we mean the callback registered by the useEffect. Okay? We call them effect just for to be a bit more simple in the discussion when we address them. Okay? But actually it's the callback registered during the render phase with the useEffect. Okay? So we say the effect. Actually, React runs the effect. Is multiple 3 changed? Previous was 3, current was 4, is false. So it runs the third effect, the third callback. Again, you remember, right? Multiple flag is false. Next time, the number has changed, but flag is false, it stays false, and so the callback is not called again. Okay? So I didn't have enough space to put this case, right? User clicks, goes to 5, and so on. Just the props num changes, but is multiple 3 stays the same value, Boolean. Okay? Okay, good. So we understood more or less how the useEffect works, right? So we can execute code after the render, so as a side effect. We don't care about what the code does, because it's outside the render phase, so it has not to be pure, okay? It's outside the code that has the return value that decides what to render, okay? So there we can do anything we like, including side effects. And so now we have the possibility to do many more things with our component, right? Okay. Just before going on and discussing, what can we do and so on, let's see one bit more interesting case, I would say. Okay, so a state variable may be directly listed as a dependency in an effect, so in the array of the useEffect hook. Okay, as any other value. Okay. When the state changes its value, the effect is run. If the state is updated through the set state, but the value doesn't change, the effect is not run. Okay? But also it's not re-rendered. Okay? React always compares the previous value with the current value. Inside the useEffect, you can do whatever you want. You may even schedule a state update. Okay? Or you can even perform a state update. Okay, that's a bit more dangerous, because if you change a state on which the useEffect depends, you create an infinite loop. Okay, that's for later in the slides. Okay, so you need to be careful. You typically schedule a set of the state. Okay, you don't do it immediately because you risk creating a loop. Okay, so the state will be updated after the effect is finished asynchronously. So after that, before the next render. In any case, if the state value changes, components are re-rendered as usual. So the rest happens the same. The state change can be triggered also by any async event. Okay, async event means, in our case, for instance, data from the server has arrived. That's great because we have a way to set the state depending on the fact that some data came back from the server. Okay? Or maybe a timeout expired and so on, as in the example we are going to see in a minute. Okay? So now actually. Schedule a state change in a useEffect. Function quickGate, a new component. Okay? It takes props, but I think we don't use any prop here. We just have a state. This time the state is not coming out from outside as a prop, but actually it's inside the component. Open, set open. Use state, false. Okay? Like a gate. It's open, it's false, so it's closed. Okay? It opens, and after a while it should close. Const open me set open true, so this is just an event handler that is connected to the onClick event on what? On some text, okay? Span, go, span, stop. So this is just a text. We could have a button. I mean, we don't really care, okay? We can have the onClick event on almost on anything in JSX, okay? So stop means closed, so open is false, stop, open is true, go, okay? What are we doing here? useEffect. So open, set timeout, set open false after 500 milliseconds, okay? So at mount time, we render the gate false, so it's closed, stop. But after the render, there is the commit phase, and the set timeout is executed because at mount time, the function, the callback of the useEffect is executed. Set timeout, set open false in 500 milliseconds. Then nothing changes. We don't do anything as a user. And then the 500 milliseconds timeout expires. And so the set open function, actually this function they call the set open, is put in the callback queue of JavaScript. It is executed. It changes the state in React. React knows it because we use the function that React gave us. So it knows that the state in quickGate has changed. So it must re-render the quickGate. So it calls the quickGate again. It re-render the quickGate, so it recall useEffect, but this set timeout, set open false, I mean, that's for later again, and we render div open, now it's true, and so we have go, okay? No, sorry, before we had to click, okay? So it's still false, so it's still stop. If we click, it's true, it renders with true, and then it does the set timeout, set open false. So in 500 milliseconds, the set timeout, I mean the set open false will be put in the callback queue, it re-renders, and it set the open to false, okay? So let's try the behavior so you understand how it works. I think I put 1000 here just for convenience. So up the quickGate is here. Yes, 1000, so you can see it a bit better. And so that's exactly the code on the slide, right? So have a look here at the stop. Let's clean up the console. Click, okay? You click, and then I do nothing, and it goes back to stop again, okay? So we scheduled an event asynchronously, okay? And note that we didn't do it in the event handler, okay? We do it depending on the value of a state, okay? So every time we change the state with the click, because the click implies calling the event handler and changing the state, the useEffect sets a callback to be executed when a value changes, and this value is a state. Okay? This, of course, is a very simple example. We could achieve the same behavior basically by, almost the same behavior by doing the set timeout here in the event handler. Okay? But I mean, this is just to show you that we can schedule state updates depending on the value of some variable that we have inside the component. And in this case, it's a state. And we use a state so that we can easily modify it. So this is the timeline of the action that happens. Component QuickGate is created and mounted in Appen, so the function QuickGate is called. The user state creates the state open with the default value false. Okay, this until now is what we saw in past lectures. Then we have the useEffect. useEffect registers the callback, so the set timeout is not executed yet. Okay, it just register. It's a callback to be called for later. Okay, const open me and so on. We return JSX with the value that is stop because we started with the false. Component just mounted, and so in the commit phase, React decides, React does this operation. So it runs the callback of the useEffect. Set timeout is executed, timeout is set. Okay? And then we do nothing. Until now, we do nothing. The timeout expires. The function that contains the set open false is executed. Okay? State open becomes false. So we have set open false. It's already false. Nothing happens. React doesn't re-render the component because the state didn't change. We call it the state with the value that was the previous value of the state. That's fine. Sometimes it might happen. Okay? Okay. And then again, nothing happens until the user does something. We clicked on the stop string, and so we activated the event handler on click open me, which has set open true. Okay? So the user clicks, the open me callback is called, the set open true is executed, state open becomes true. And so now React now knows that the component has to be re-rendered because the state changed. The JSX is returned with the go, so you immediately see the go when you click. Immediately see the go. And then, again, the useEffect has registered a set timeout, set open false after 500 milliseconds. And then 500 milliseconds passes, and the useEffect, the useEffect first find the open has changed, so it registers. The useEffect has registered the callback. Okay, then the open has changed, went from false to true. Okay, and so the set timeout is executed. We set the timeout, and then we are at this point, and we need to wait that the timeout expires. Okay? 500 milliseconds pass, and then we call. Not we, but JavaScript. The environment calls the set open false because it's a JavaScript timeout. Okay, it's not a React timeout. Timeouts are from JavaScript. Set timeout is just from the JavaScript environment. Right? So this function is executed, changes the state in React. State open becomes false. Component re-renders, and so we see the stop. Okay. And now note that useEffect finds that the open has changed from true to false. So it scheduled the set timeout for 500 milliseconds, set open false, even though if it's already false. Okay, but then the timeout expires, and then set open set to false, nothing changes, nothing happens because the state is already the value false, okay? So if we don't want to this double execution of the set state, we need to write the code in a different way, like if open is not false, set timeout, set open false, okay? But the callback will be executed anyway. We just don't want to execute a part of a callback, but the callback is executed anyway because the fact that the callback is executed depends on how the useEffect has been defined. And the way in which the useEffect has been defined is just this one, okay? Every time a dependency value changes, the callback is called. You can write whatever you want inside the callback. The callback is called. If you don't want to do something, you're free not to do something, but the callback is called, so you start your code with an if. Okay, if and do something, otherwise, I mean, the function is finished and you don't need to do anything. Okay? So that's maximum flexibility from the point of view of the programmer and sort of simplicity from the point of view of the hook that we are using, so this useEffect. Okay, I'm looking at the mobile phone because I forgot the watch today. Okay, so just not to overrun the time for the lecture. So, make sure that you use the correct dependencies in the array of dependencies for the useEffect. Okay? So you should, in general, make sure that the array includes all the values from the component scope that change over time and that are used by the effect. So in short, if you use some values inside the useEffect function, let's see the previous example, props num, typically props num or some value that depends on prop nums has to be listed in the list of dependencies. Okay? Because I mean, you typically want to run this function because something has changed. So this is sort of sanity check, okay? Otherwise, you risk that your code will reference state values or old values from previous renders, okay? Note that if the array includes variables that always change when executing the effect, you risk having an infinite loop, okay? Because the useEffect always schedules the callback. If the callback changes the value on which the useEffect depends, so it will call the callback again, and you have this loop. Okay? At a certain point, this loop, I think, will be interrupted by React because it knows that, I mean, it detects that after a certain number of iterations, probably there is a loop. Okay? So it just guesses there is a loop. But, I mean, this is a wrong way of writing the code, okay? Because we are keeping the code busy doing nothing, typically, for no purpose. Okay, let's do the last part of today's lecture, I would say. And then we will practice a little bit on our example with the question and answers. Okay? So, using the fetch is the function that allows us to load information from the server. We already discussed this function in the lectures. And it's from the browser environment. Okay, it's a modern way of loading URLs and interacting with the server. And the client, in this case, we have a client that does a very simple stuff. It takes some value that has been written by the user in a text box, like in a form. Now we know how to handle a form. It sends this value to the server, and the server simply replies with a string which looks which looks like an inverted text. Okay? I mean, it's just a toy example. I mean, we are using a library that inverts the text. Basically, there's just taking some characters as a mapping that says, like you see, the W becomes a sort of M, the O stays the same, the A stays the same, the E, there is a symbol that looks like an inverted E, and so on. Okay? I mean, but we don't really care about how it works. I mean, this library, you pass a string, it gives you the inverted string. I mean, we could simply swap it from end to start, I mean, anything you like. Well, the important point is that we want to interact with the server, right? And so we want to send some information to the server and get a response from the server. That's an asynchronous event that needs to set a state because it's a form, okay? Well, actually not in the form, but I think we will, no, not in the form. We will set it in the place where we display the value, but it's another state, okay? So basically we have this situation. So we have the browser, we have this initial request, always to localhost 5173, that is the web server run by Vite, so the one that we used until now. Plus we have a second server, the API server. You remember in the first lectures in week 2 or 3, we had this API server, we interacted with the server through this REST client, okay? Or even with the browser for simple GET operations. And that's fine, and now we put all the things together. So from the browser, we issue a fetch instruction that goes to localhost 3001 / something, and we will have an API that answers with the value we would like to set. And the point we need to understand now is not how to write the server. We should already know how to write the server. We already saw it at the beginning of the course. But we would like to understand how to use the value that is returned to the server, how to show it to the user, and so on. So let's see the code, and then we will test it, okay? We have 3 different versions of this code, because, I mean, it's really important to understand how things can become quickly, I would say, difficult when there is a server involved. So something that generates asynchronous events, okay? So example, text flipper props, it has a form, input type text, value text, on change, handle change. That's a standard form, right? Controlled form component. Value text, text is a state. In the beginning it's empty. Every time there is a change, we handle the change, set text, event, target, value. Sorry. Event, target, value, and we set the value in text. That's fine. Great. Okay. Now we need to tell the server, actually, I have a different text. I want to get the flipped text version of such a text, okay? How can we do it? Well, we could send a fetch here immediately. That's one option, okay? It has a number of, say, drawbacks, okay? So we cannot really handle concurrency very well and so on. But, I mean, that's for later in case you have questions. Let's try with what we learned today, the useEffect. useEffect has a callback. You see the open curly bracket here, which is closed here. Okay, so this code is from the useEffect callback. And there's a list of dependencies, an array. There is just a single value that is a text. Okay, remember that a string is a basic value in JavaScript. So every time the string changes, JavaScript, has a new value for the string. And so React knows that the string has changed. Okay? And so when React knows that the string has changed, it calls the callback. And the callback does this operation. So it defines an async function, rectext, takes a rectext, so a parameter, issue a fetch and await for the fetch, okay? And then await for the response that comes in JSON format, so we will assume the response is in JSON format as we will do it until the end of this course. And then it's set a state, set flipped, okay? Of course, the set is not done immediately because we have two awaits, right? So we are blocking the code here, waiting for the response, and we are blocking the code here, waiting for the parsing of the response in JSON format. And then we have a response body, an object that corresponds to the JSON that has been sent back from the server, from which we take the value text and we set it here in the state. Not in the state of the form, but in the state of flipped, that is what is shown. Okay? Typically, this is very common pattern. So when you get information from the server, since it's an asynchronous event, if you want to display it, you need to put it into a state, because you need to trigger a re-render. And the only place where you can put new things, which is not read-only like props, it's a state. So typically you have a state to set when you get an answer from the server. Okay? And this then triggers all the operations after the set of the state, as we saw until now during the course. Okay? React is about setting states and waiting for the interface, for the user interface to change. Okay, that's a server. Very simple server, right? Express flip import app express listen 3001 / flip app get. So we issue a get request that is the default HTTP method for fetch / flip get rec. We read rec query text because we encode it as !" text equal to. This encode URI component is from the JavaScript environment inside the browser. Just make sure that you send characters which are allowed inside URLs, since the user can type anything in the text box, and this function converts it into something which is a valid URL without changing the meaning of the characters. And if this was a body, I could have done with a post, with a body and so on. This would not have been necessary, okay? Would have been converted by JSON, stringify and so on. But just to keep the thing simple, since the answer only depends on one single parameter, it's fine to pass it as like this, okay? And so we get the text, we pass it to this library flip, okay? It flips the text and we return back the content with the flipped text using an object, text, key text, value flipped. And that's why you have dot text here, okay? Because this is an object that is converted in JSON format for traveling back from the server to the client, okay? Let's try the example. So I have this example. I think maybe I just need to uncomment it. No, it's just here. Text flipper, okay? So let me show you the text flipper is what you saw on the slide. Almost, there is just this waiting state that is the next slide, but works almost the same, okay? So let's test the code. How do we test it? Okay? It doesn't work. Okay? Why? We need to run the server, not only the client. Okay? We need to activate the server. The server that is currently running, it's the web server started by Vite. But this web server only serves the application with its JavaScript code. Okay? So how do we run the server? We open a second terminal. New terminal. Here. So, sorry, we need to change the directory again. WA-2026 lifecycle examples, server. Okay. Server is very simple, it's just one file. This index.mjs server. Okay, that's what you saw on the slides. Almost, okay, because it's a bit more complex for next examples, right? But this is the code that you saw on the slides. Flip text flipped, okay, res.json text flipped. Just takes a little bit more time because I inserted the random delay and so on to show you something later. How do we run it? First, we need to install the packages. Don't forget about it. npm clean install, npm, node mon, okay, this is not npm anymore, it's not configured in package.json, nodemon index.mjs. Okay, running on port 3001. Good. So we have one server here running on port 3001, and you see the other terminal here. There is another server, Vite server, that is serving the web application on another port, 5173. Okay? So let's reload the application. Okay? Okay, that's the old example. We didn't do anything yet. A, B, C. Okay? You see something happens, right? D, E, F. Okay? I mean, don't focus on the graphical aspect of the inverted text, because it's just a library that does, take some characters as they are available. Okay? I mean, no, not everything is perfect, right? But I mean, the important thing, have a look here at the network tab. This is really important. I will always have the network tab open at the exam when testing your submission, because I need to understand how client and server speak together. Okay? So let's start again. I reloaded the application. Of course, I mean, in the beginning it loads from Vite, etc. But I don't care about this stuff, because this is just standard handled by Vite. So let's clean up. And then A. Okay? So you see, as a request has been sent from the client to the server. The request is get HTTP localhost 3001 flip question mark text A, and then we get a response in JSON format. Okay, that's a JSON format. Okay, and that's the inverted A, just a character as many others. Okay, could be a Chinese character, I don't know, whatever character. Okay. Okay, B. Another request is sent. We wait for the response. Once the response arrives, it is parsed, and then it is set in the state, and then it is rendered here. Okay, let's do C. And you see that when the response arrives, and you can see it here in the network tab, when the response arrives, the response is rendered. Okay, C arrives and it's rendered. Okay, how does this happen? Let's have a look at the code. Client. So text is the content of the form where I type ABC. Okay, AB is already typed in C. On change, okay, on change, set text, event target value. The state changes. The component is re-rendered, so the function text flipper is called by React. When the function is called by React, the useEffect is called, so it registers the callback, that is this whole function, and takes note of the fact that text now is ABC. Okay? Then it renders, so we have an immediate update of the value of input type text value text, so ABC, the C immediately appears. And then in the commit phase, the callback is executed. Okay? So the callback is executed means that the callback goes and, well, it defines a function. This is just a function definition. It calls the function fetch flip with text. Text is the new value of the state, ABC. And then, what does it do? Fetch HTTP localhost 3001 flip text equal to rect text, that is ABC. Then nothing happens. We wait for the response of the server. That's why I introduced the delay, so it's easier to see that we wait, right? Because this part flipped doesn't update immediately. You need to wait for the answer from the server. Let's try. You see, we wait, and then we have the answer. When we have the answer, the code resumes from this point. That's how the await works. You remember the promises. Promises fetch immediately returns a promise, but the await basically stops the execution of the code. Okay? It stops the execution of the code. It resumes when the promise is solved. Okay? We say it's settled. Okay? Solved is a bit more generic. It's settled. So the promise is fulfilled because there is no network, there is a network connection, there is a response from the server. The promise is fulfilled, and it's fulfilled with the value that is a response object. So response is a response object. Okay, the code resumes the execution, so it's put again in the micro callback queue. Okay, in the micro tasks queue, we call it. Response.json, it returns again a promise. We wait for the parsing of the JSON. This is particularly simple, so we don't wait that much. But again, the result, when the promise is settled, the promise is fulfilled, we get the result from this promise, and the promise value is the object that corresponds to the JSON that has been passed. So it's an object because it starts with a curly bracket, right? It has one field which is text, and indeed we do response body dot text. What do we do? Set flipped. We set the state of the component. Okay? And also this waiting force, in a minute we discuss it. We set flipped. And so React knows that now a state inside the text flipper has changed. Okay? And so it re-renders the component. So it calls this function again. Text, useState has still the same value because the user didn't do anything. He just typed C or D and we waited. Okay? Okay, good. Flipped has changed. Okay, waiting, we care about this later. We set again the callback. But this time text has the same value as before. So the callback is set, but it will not be called later by the useEffect because the text didn't change. The text is the content of the form. But then text is rendered, so the content of the form stays the same, but the flipped changes because it depends on the state that has changed. So that's the whole set of actions that happened. Okay, I recorded it. I know maybe you missed one step and so on. Okay, so it's quite long, but you need to understand this cycle, and then you will think in these terms quite automatically. It's not that difficult. You change a state, you re-render, you pass again through the useEffect. The dependency did not change. Okay, that's fine. This will not be called again. That's a summary. Okay, but all the steps in details are the one I just described to you. Okay, so let's see it again. We can even put space, anything we like. Okay, and when you see every time we type something, let me see the request. Yes, ABC with a space. Request. Not easy to see here, but you see there is a space. Okay, ABCDS and so on, and the flipped value will change. Okay, G, H, Y, I, and so on. Okay, good. Let's spend just 1 minute about the waiting, and then we will do the break. Okay, so waiting is an additional state. It's convenient. Yes, it's convenient because if we don't get the answer from the server immediately, as it happens normally, normal web application in the real world, it might take a while to get the answer from the server, even though it's just hundreds of milliseconds and so on. Users are so impatient nowadays, right? You can notify the user of the fact you are waiting, right? So how can you do it? Use an additional state. So you see, what's this state? So true. Waiting. Oh, here it is. Okay. So useEffect. When you detect something has changed, you set the waiting to true first thing, and then you start the operation with the fetch. Inside the operation of the fetch, at the end, you set a new value for the text, so it will get re-rendered, but you also set waiting false. It's just a Boolean flag that decides to show you this clock, okay? Could be a spinner, could be anything you like, okay? Just to let the user understand it's waiting, right? H, you see the clock, okay? This clock here. Just to let the user you are loading data, okay? Some applications like to write loading, some applications like to make an animation or whatever. It's very simple to achieve. It's just an additional state. You set it when you start the asynchronous operation, you reset it when you finish the operation. And here you have the place where you can do this operation, okay? The beginning and the end of the asynchronous operation, okay? And this works because we have the await, of course, right? Otherwise, there are promises, and we need to have then, and so on, okay? That's the usual stuff with the promises. Okay, I think I spoke too much, right? I mean, yeah, just a couple of issues that maybe it's better to think when to talk about when we are back from the break, okay? So we have fresh mind, because they are important. There will be topics for next lectures, okay? So if you have any questions, I'm glad to answer. Otherwise, I think we can break for 10 minutes as usual. No questions, right?